All right, let's look back at some of the rules for exponents. I know we know these, but just to review, a to the r times a to the s is equal to a to the r plus s. In other words, if you have exponents of like bases and you're multiplying, you're going to add those exponents. A to the r over a to the s. If you're dividing, you're going to subtract your exponents. If you have a power raised to a power, you're going to multiply those exponents. AB to the r power, that just means you'll raise each one to the r power. And same with division. All right, and then rules for negative exponents, we've already talked about this. A to the negative r, you're going to flip it and make it 1 over a to the r. If you have a over b to the negative r power, flip it and make it b over a to the r power. All right, so we want to simplify each expression. 2 to the 1/2 times 2 to the 1/4. All right, so here we have exponents of like bases. We're going to keep that base the same and add the exponents. So 2 to the 1/2 plus 1/4 would be 2 to the 3/4. And you can leave it this way. You don't have to write it in radical form. You can leave your answer in exponential form. And that is a plus sign, by the way. There we go. All right, 5 to the 2/3 over 5 to the 7/3. We're going to subtract those exponents, and just remember that the larger exponent determines where it will go. So that will be 1 over 5 to the 5/3. All right, this one, we have a power raised to a power, so we're going to multiply. All right, and 1/2 times 4 is 2, so that'll be x squared. And then 2/3 times 4 is 8/3, so y to the 8/3 over y to the first power. So the first power, I can write that as the same as 3 over 3 because I want to have a common denominator. And then you'll subtract, and so that'll be x squared y to the 5/3. All right, so this one we have a little bit of everything. So x to the 4th power, y to the -6 over x to the -2nd, y to the 1/3, and then all of this is to the -2/3 power. So I'm not exactly sure, you know, how you would do this, how you would want to do this, because there are many ways you can do it. So you can go ahead and do your power raised to a power and multiply first, or you can simplify within your parentheses and do your subtraction first. There is no right or wrong way to do it. It's just whatever way you would feel most comfortable. So let's see. Why don't I'll do it the way the book's doing it. So power raised to a power. All right, so that'll give me x to the 4 times -2/3 would be a -8/3. And then y to the -6 raised to the -2/3, you'll multiply, and that'll be y to the +12/3, which is the same as y to the 4th. All right, now we have x to the -2nd to the -2/3, multiply, that'll be x to the +4/3. And then y to the 1/3 times -2/3 will be y to the -2/9. All right, so now I'm going to flip the terms that have negative exponents. So this one will go to the denominator. This one will go up to the numerator, and the other two will stay where they are. So let's see. Now we have y to the fourth, y to the positive 2/9, x to the 4/3, x to the positive 8/3, and we have exponents of like bases we're multiplying, so we're going to add the exponents. All right, so looking here, this is the same as 4/1. LCD would be 9. So I would multiply both numerator and denominator by 9. So I'm just going to rewrite this as y to the 36/9, y to the 2/9, x to the 4/3, x to the 8/3. Just rewriting it with a common denominator. All right, so that will equal y to the 38/9 and x to the 12/3, which is x to the 4th. And that's the final answer. All right, let's try one more. All right, so we're going to distribute, and since we're multiplying exponents of like bases, we would add the exponents. So that would be m to the 8/4. All right, you'd add the numerator, keep the denominator, minus m to the 4/4. All right, m to the 8/4 is m squared, and m to the 4/4 is just m, and you would leave it just like that because they're not like terms. All right, and I think this is actually the last example. We want to write each radical as an exponential and simplify, and then leave the answer in exponential form. So not in radical form, but exponential form. All right, first one is the cube root of x squared times the 4th root of x. So first let's rewrite them as exponentials. So that would be x to the 2/3 times x to the 1/4, like bases, and I'm multiplying, so I would add those exponents. I'll just write it out here. Add exponents, and in order to add the exponents, you would need a common denominator. Common denominator is 12, so I would multiply this fraction by 4/4 and this one by 3/3. So now I have x to the 8/12 times x to the 3/12, add and get x to the 11/12. All right, the square root of x cubed over the cube root of x squared. First, rewrite them as exponentials. So that would be x to the 3/2, because that's the square root, over x to the 2/3. This is division, so you would subtract your exponents. And we would need a common denominator, which is 6. So I would multiply this fraction by 3 over 3 and this one by 2 over 2. So now we have x to the 9/6 over x to the 4/6. Subtract, that would be x to the 5/6. And one more. The square root of the 4th root of z. So this is the same as a power raised to a power. So let's start from the inside, meaning here, and work our way out. So the 4th root of z would be z to the 1/4. And if you take the square root of that, that would be raised to the 1/2. So a power raised to a power you multiply, that would be z to the 1/8. And that is all.